the ones that are deploying it have that information of what went into the AI.
It's only been trained on.
So they know where to apply it. And that's where the trust transfer happens. The ethical use would be, I'm going to only use this on populations that match my data sets. Or if I'm going to use it in other ones, I have to recognize my weighting should come way down because I'm not going to get good results. So step one is having that good data sourcing. And that's a really important process to get the ball rolling.
Welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology.
This is Darren Pulsford, Chief Solution Architect, author, and most importantly, your host.
On today's episode, securing the GenAI DevSecOps pipeline with returning guest Steve Oren, CTO of Intel Federal.
Steve, welcome back to the show again.
Thank you, Darren. It's a pleasure to be back here again.
Today, we're going to do the second part of this interview. We want to talk about the DevSecOps, specifically, if I can talk, the securing of AI development. That's what we want to talk about today. Our previous episode, we talked about how to secure an AI that's been deployed and the new techniques that are out there, new companies that are out there, really cool stuff. Steve, let's just dive right in. So, can I just use my normal DevSecOps pipeline? Or I hear AI ops, AI ML ops. It's just DevSecOps, isn't it?
No, it's not just DevSecOps, but it is DevSecOps for AI. And so let's talk about this.
Okay.
So before we dive into the gory guts of how do you secure the whole development life pipeline, let's talk about the why. And here's the why. Everyone, governments, international organizations, companies, people are talking about this concept of ethical use, trustworthy AI. Well, what does that mean? At its core is I need to be able to trust that this AI is going to do what it says it's going to do and not going to do it with intrinsic bias, not going to give me false information, and is going to protect itself and the deployment side. So to get to that notion, I mean, there's all these talk about it, but no one's really looking at how do I do that? How do I trust an AI? It's not because I got some security widget at the end. The way you trust AI, let me finish. The way you trust AI is getting that deep visibility and controls throughout the life cycle. And that's why we're going to talk about the DevSecOps. But you have to understand, how does an AI get built to understand what to apply to that pipeline?
Right. So exactly. AIs get built with data.
Yes.
Right. So that's the new element in the AI ML pipeline, right? I've got to protect the data that it's being trained on. Now, here's a big question, because my background is DevSecOps. I've got patents in it. I've written books on it. So I know this area really well. Repeatability. I can't do that with AI ML ops. It costs too much because it takes hundreds of thousands of hours of compute hours to build these models. I can't just say, oh, well, I'm just going to, it went south. I'm just going to redo it. You can't do it. So that's a major change. So what am I going to do?
Well, so let's start at the heart of it. So when you do DevSecOps, what is the mechanism? What are the atoms, the building blocks? It's code in that case.
Yeah, it's code, right. And scripting and binaries that I bring together. Right.
It's code that allows you to achieve a goal based on a set of requirements. Well, here's the key around AI, ML ops, or whatever you want to call this next wave. The building blocks isn't code. Those are a means to an end. The building blocks is data. But the key thing here is when you're talking about the beginning of that process is the requirements to have the right data. So it's not that you have security or controls of the data once you have it, but it's having the right data from the get-go. And this is where we can help to deal with bias, or we can help to deal with getting trustworthy sources. So first step before you even start doing any of your actual coding or fun is knowing where your data is coming from, who it's coming from, what's the lineage or the provenance of that data. And not just, okay, I've got a good set of data, but now it's the soft part. So I'll give an example. You want to do a medical AI. So you're going to go out into the market and you're going to find, okay, I've got a set of scans of people that have got a particular condition. I'm going to import that data set. Great. And I can secure it. I know it's coming from a legitimate university. That's awesome. But here's the soft part that actually goes to the heart of bias. What was that data set collected from? Well, you find out it was 18 to 35-year-old white males. Okay. That's in one data set, but that's not complete from a bias perspective. I need to have diversity of data to build a good AI. Your AI is only good as the inputs. So now
we solved this problem with China.
Exactly.
China had incredible AIs. Incredible AIs for facial recognition, but they were testing it only on people from China. As soon as they tried to test it on people in North America, it fell apart.
And we see this in every industry. Every industry, they train it on a data set, and then they go live, and they realize their data wasn't complete. So the first step in doing a AML DevSecOps process is starting with building in diversity in your data to begin with. And so knowing that because the resulting AI is going to be applied to a much larger population. And so that's step one, having not just that you can know the data source, but that you have goodness in your data sources. So starting there, we want to make sure we're getting them from legitimate data sources that have enough diversity in the data set, or getting other data sets to augment that, or in many cases, using synthetic data to help augment your data sets in order to give you that diversity. So that's step one, to help identify and at least start with the problem of how do I get better understanding of what biases are there, but also documenting that. So let's say you only can find data for 18 to 35 white males, white females, and African-American females. And that's your starting point. So it's all you've got. You maybe can put a little synthetic data or some perturbations, but then what you do is you document that so that at the end of the process, when you're deploying that AI, the ones that are deploying it have that information of what went into the AI.
It's only been trained on.
So they know where to apply it. And that's where the trust transfer happens. The ethical use would be, I'm going to only use this on populations that match my data sets. Or if I'm going to use it on the ones, I have to recognize my weighting should come way down because I'm not going to get good results. So step one is having that good data sourcing. And that's a really important process to get the ball rolling. The next part is, because there's a lot that goes between, you've got your data here and your AI all the way over here. There's a lot that happens in between. We often call that the iceberg principle. The AI is a little cool, sexy thing at the top, and there's the data management,
stuff underneath it. Right.
The data wrangling, the governance, the curation, all that happens underneath, but it's necessary in order to achieve that goal. And so having good practices, this is where your DevSecOps comes into play at every step of that process, so that you have the data labeling. And how do you label it? Like, where did you get your sourcing for that labeling? Was it automated? Was it human interaction? Was it curated? All of those things have to be documented and attestable, so that you can then build on this foundation. And what you're seeing here is we're building a foundation of trust. Good data sources with diversity documented. The data labeling. How did you go about labeling data? How did you go about curating the data? What governance policies were put on place for the transfer? When you did the tuning, when you started doing the training, what was in, what was out, what was considered acceptable? So you said, well, 75% recognition was good enough in my dev environment. But if you divorce that from what the end state is, where they're going to want 90%, you're going to have a mismatch. And vice versa. If you only train for the 90% match, but they don't care, and they're going to open the aperture, on the front end as far as weighting, you need to train for that early. So it's having that governance and requirements built in and documented throughout the process. You still do a lot of your DevSecOps models, but you're doing them with this extra step of building on and transferring the information each stage.
Right. So to me, this is good DevSecOps, period. You're treating data, though, as a first-class citizen.
Yes.
Because if I treat it as a first-class citizen, then I do have auditability. Good DevSecOps has full auditability from the time code is checked in. And instead of code, I'm checking data in.
In essence, and the functions that you do on the data.
And the functions, and as data changes, it's derived data now. And I have true provenance all the way through. The big question is though, we're talking about petabytes of data going to train these models. Am I checking petabytes of data into a SCM, into a change management system now? I don't know. I mean, this
is where there are techniques that are available when we deal with petabytes of data in any other model. So things like hash functions, using a blockchain. There are techniques for referencing a big bucket of data with an indicator that I can use as a binder to be able to trace it.
Yeah, but at the same time, I have to treat data as individual objects
But they're a collection. Yeah.
Or a collection or a small
Yeah.
collection. But because let's say that I have trained my data and I trusted it and all that, but I find out later, because this happens all the time, I find out later that data source that I trusted turns out that it wasn't very trustworthy. So how do I have to be able to identify that data, pull it out of the pipeline so I'm not training on it anymore? And do I have to go back and retrain the model? Maybe, maybe not. Maybe I just don't do reinforced training with that. So I do need traceability. I need accountability. I need auditability all through this whole thing. This is a big endeavor. And I can tell you today, that is not happening.
Absolutely. And so, Darren, you brought up some really interesting points there. So think about a different model, and then we're going to make it worse with AI. But if, let's say, you pulled down an open source module and built it early into your code and then use it for a variety of things, a log4j, for instance.
Yeah, and now, that's a great example, log4j.
Yeah, and let's say you've used it in 16 parts of your application that you've deployed. You find out it's vulnerable or it's bad, and I got to go yank it out and replace it with something else. I got to go back to my code. Sometimes I've coded direct API, so I got to maybe change the API. There's work that has to be done to go back, but you need to know that you have.
I can see that.
Yes.
In an AI model, I can't. Right? It's weights that are combined over hours and hours and hours of training. I mean, there's no way to forget.
That's the key here. So what makes AI different is the fix. But the first step is the knowledge. If you don't know that you've found a bad data source or there's an intrinsic bias that you weren't aware of, if you have none of that visibility all the way back to the data source, you're basically hosed. However, if you know that this data source, and let's say the data source was 18 to 35-year-old males, was actually all corrupt.
Right, like we talked about.
Right. All right. If you know the data source and where it came from, and you know that where it was brought into the pipeline, you're not going to be able to undo, because once it's trained, that's in there. But you know what you need to do now as a follow-on process to help train on better data and help move the model. Or there's the other thing to keep in mind on the front end, look at it from a weighting perspective. If you know that you've got corrupt data or biased data but you've been training on other good data sets, it may change your confidence scores. It may change your weightings to be able to compensate. But there's a maxim out there that says, that, and this is not 100% true with large language models, but there is a concept in a lot of the CNNs and DNNs. For every piece of bad data, I need to train with 2 good pieces of data just to get back to normal. Not to get better, but two for every one.
Back to normal. Well, it's like humans, right? It's like us, right? If we learn something bad, we gotta learn something. We gotta relearn it, and it takes more time.
And it's more data points to undo the bad. LLMs are worse, by the way. There was a paper that I think a Google researcher put out that said if an LLM, a certain size LLM is trained on bad data, you can never unlearn that, and that might be true. The problem is we just don't know for some of the complexity of these large language models on the sheer scale of the data they're learning. But here's the flip side. The scale of what we're learning helps mute or dilute a lot of that big data if we had good diversity from the get-go. And that's the reason why I brought that up first. If we have good diversity of the data, not just different types, but even of the same type, multiple copies of that same type. So if you have 1835 white males from 3 different universities, even though it's the same category, but I've got diversity of source.
Diversity of the CT scanner or whatever, because you could have a CT scanner that had speckles. I mean,
exactly.
There's a case on that.
But what we're doing is we're basically diluting the adverse effects of any one set of data causing catastrophic. It's still bad, but that's why having good sourcing is, especially in these very large data sets, helps you get that dilution capability. And then knowing it, if I need to do some additional training or some additional reinforcement by knowing what data set went bad, I know the data set type that I want to use to help up the ante on that one. Again, a lot of this is what's going to make a lot of people upset though. This isn't an exact science. It's not saying, well, I need 12 petabytes of data to compensate for 7 petabytes. There's no easy math.
It's not. So here's another idea. This is another crazy Darren thought. If I can also keep a temporal aspect of when data was injected into a model, and I can roll back a model to that point in time when that data first came in, I don't have to do the retraining of the whole model. I can go back in time and say, I'm going to retrain the model from this point in time where the data was injected, and I'm not losing as much time as I did before. I think that could be an interesting play.
Definitely for certain use cases, and where that will be more usable is in the domain-specific training models, where you have where you don't have the infinite possibility of inputs. Because if you say I'm going to roll back 6 weeks because of this data set was introduced, but all the other data that was introduced in that time will also be lost, you lose a lot of your value chain, and that actually could be critical.
My confidence level could go up. So I guess it depends. To me, it depends on the how much risk you're willing to take with this LLM that you're creating.
Yeah, and where you're applying it, And this goes back to knowing what you're doing with the AI and what domain you're focusing on. But I think what I want to go also to one of the things we straightened some of the soft art part, which is important. But I think the key thing, just like you've started to talk about, there are certain controls that we need to put in place in the whole AI ML ops pipeline to protect not just the temporal aspect or what data sets, but also check the same things you do for code. Who did the training? When did they do the training? What system? Was that system compromised? Tying together the infrastructure to the action to the person, recording that, and being able to keep track of that throughout the pipeline as part of that good process is how we get that visibility and those controls, so that if something goes on, if we learn 6 months later that we had a breach at that time, then we can go back and say, well, who was using a breach system to work on this AI? Okay, we can now understand that there's a risk to the AI. Today, we have no visibility. We have no way of knowing. And so building those controls in are important.
Would you suggest a secure ledger concept? We architected something together, the hardened DevSecOps concept. Yeah. To me, this fits perfect for that because there's a secure ledger. Things are run in secure enclaves, so there's no side attacks in the DevSecOps process. Do I really need to lock it down that tight?
I think that's an exquisite use case for certain really sensitive things, but I think practically having a ledger, having even a data structure,
ledger would be better than nothing.
Exactly, and for a lot of use cases, that's going to be good as long as you keep that separate. And you can go back and verify that ledger to know what happened at a given time, to know what functions have happened, when code was brought in. Like you said, when code was brought in, when new data, when you start doing your model tuning. And that's where a lot of the soft art goes into play, where someone is tuning and optimizing a model. They may bring in data sets. They may make decisions, personal decisions about what to do with an AI based on their intrinsic bias. And so, again, having good visibility and controls into what's happening at each stage and making sure check is when you find something has gone wrong, you can go back to its source. Okay, here's where it went awry. This is the problem. I can now either correct it or make better next time. Today, we don't have any visibility. And so the theme that I want to leave everyone with on the DevSecOps for AI/ML is visibility is critical in order to be able to get to that end state of trustworthy AI at the end of the stage. And you trust it based on the level of visibility or the level of controls. Some AIs you really care about, the ones that are going to save lives or protect lives. Some AIs are just going to be, well, did you bet the right on a stock because the AI told you? It's going to have a value, but it's not going to be the same. And some are going to be, did I get the right Christmas present for my kids? Those are going to be different levels of risk. It could be for a couple of weeks, yes.
Yeah, it could be. So to me, it sounds like we want to get back to basics. The basics of good DevSecOps. Try and wrangle the Wild West as it's going crazy right now, and get back to some fundamental basics on software development, AI development. We got to figure out a way to take all those Jupyter notebooks that are just free form, whatever, and put those into some kind of repeatable process, DevSecOps driven type of protected pipelines that are generating repeatable AIs that are going out. I mean, that's what it sounds like to me.
Yeah. And so it's AI,
it's
ML.
A heavy lift. I'll just tell people now, this is a heavy, heavy lift. You're going to have to pull me out of retirement to help with this when I'm old and pay me like $2,000 an hour to do it, I'm fine with that. You could do that. That's all right.
Yeah, I think we'll get a bunch of college graduates that'll do it better. But yes, no, but I think
maybe
that
I'll
you're
start learning COBOL then,
Yeah,
Steve.
yeah.
I'll go back and learn COBOL.
But I think you're right. We need to take an AI ML flavor to the DevSecOps and apply it. And if we start now, then it won't be so painful downstream. And so that's why you build these processes in now, as opposed to waiting till you've already deployed the AI and say, oh my gosh, we got to go back and try to retrofit. That's going to be much, much harder.
Right. And use the security profiling, the security best practices that we already know how to do. We don't need to reinvent something. We just need to apply what we already know.
Absolutely,
this is
Darren.
great.
Thank you.
Steve, thanks again for coming on the show. Always a pleasure. I can't wait for our next episode. We'll have to schedule that one where we're going to talk about how to use AI to fight off bad actors because they're using AI already to write scripts. And it's crazy what's going on in the cyber war that's happening that no one's talking about.
Thank you, Darren. It's a pleasure to be here and look forward to our next episode.
Thank you for listening to Embracing Digital Transformation today. If you enjoyed our podcast, give it 5 stars on your favorite podcasting site or YouTube channel. You can find out more information about Embracing Digital Transformation at embracingdigital.org. Until next time, go out and embrace the digital revolution.